Thank you for joining us this afternoon for us, maybe morning or evening for you, but thank you for joining us for our launch webinar on our new third generation hydraulic multimeter that you can see on the screen. It's going to be presented by our Managing Director, Martin Cuthbert, this afternoon. My name's Sam. I'm the Marketing Communications Manager here at Webtec, and I'll just be your host for the afternoon. Just a couple of housekeeping things. I've disabled cameras just really for bandwidth, and if you could keep yourself on mute during the session, that would be helpful. If you have any questions during the session, by all means, stick them in the chat, and there'll be people looking at that and monitoring and helping answer them. And then we'll have a quick session or section at the end if you'd like to ask any questions after Martin's presentation. And then at the end, I'll let you know some things I'll be sending out after the session. So that's all from me. Martin, I'll hand over to you.
Perfect. Thank you, Sam. Hello, everyone. Thank you for joining us today. Thank you for joining us live. I know some people will be registering and watching this as a recording. Perhaps a bit of background as to how we're going to hold this session today. Over the last few years, we've done quite a few webinars, and we like sharing technical training material, and we also like to do this from the point of view of the user. So rather than just telling you lots of facts, we thought we'd do it more as a story from the user's point of view, as we found that's been more engaging. And so hopefully that's going to work for you today. We expect it's going to take about 30-40 minutes. As Sam's mentioned, feel free to pop questions in the chat as we go along, and then we'll have a Q&A at the end. So we'll go straight into the scenario of the user. We've got a fictitious company here called Mining and Oilfield Services. As the name suggests, they're involved in both oil and gas and mining. The companies and the people are all fictitious, but bear a strong resemblance to lots of the companies that we know use Webtec products. Two particular characters we'll just meet at the beginning. Lauren is the CEO. He's responsible for the whole business, and Steve is the service manager responsible for the hydraulic machinery. Lauren doesn't want to invest lots of money in new machinery. He wants to sweat the assets, so to speak. He wants to get more out of them, but he also wants to fulfill their mission of being a safe and reliable company, but innovative as well. If we look at why breakdowns are a real issue, so Steve's been tasked with trying to minimize breakdowns for the company. And the cost of breakdowns can be really very high. And so we just look at some of the costs that make up a breakdown. So if a piece of machinery fails in the field, call up a service engineer, time to diagnose a fault, a new pump delivered, fit and adjust the pump, flush the system out, recommission it, clean it up. Total 26 hours in this particular example. Downtime cost £2,600 per hour for the cost of not doing any work in this quarry. Total it up just under £70,000. You still got to add the parts in, pump, the shipping costs, maybe some other parts. Overall, big numbers. So that one failure potentially just under $100,000 worth of cost. And when we look around and talk to people and you read articles on it, that's echoed by quite a lot of evidence from other companies in the industry. So the cost of breakdown drives a lot of these decisions. Certainly for Lauren, that's what's important to him. He wants their machinery to be operating, both because he can earn money that way, but also he can deliver on time for his customers. So where does Webtec come into this? We've been around for about 60 years, listening to the challenges that our customers have in the field. Our aim is to improve the performance of hydraulic machinery worldwide. And so there's a couple of areas where we can help. And the three-step approach that we're just going to talk about briefly here, and you'll see this leads into the product that we're introducing today, is pretty much universal across the industry. So the approach that Steve can use here to keep his machines running longer and keep the costs under control. His first challenge is that he has an inexperienced team. And so one of the first things that we would say to anybody who comes to us and wants advice about testing is to say you need to have competency-based training. And we're not a training school, but we do know some very good training schools. We have written a book, the book that you'll see on the left-hand side there, Practical Hydraulic System Maintenance. Large part thanks to Steve Skinner, who spent a long time working at Eton and doing training for them. But in tandem, we support and work with a lot of the fluid power associations around the world. So you can see that the British Fluid Power Association, the IFPS, the NFPA, the CTOP, all of them either give training themselves or have a list of accredited training partners. The partner that we know best in the UK is the NFPC, National Fluid Power Centre, and what they are very good at doing is both assessing the level that people are at and delivering competency-based training. And what do we mean by competency? It means that people have both got the ability and the skills, and they've demonstrated that by the time they've finished a course. And so that's perhaps the first step in the challenge for Steve. He's got an inexperienced team. One of the solutions there is to work with one of those partners. And if you go to our website, there are resources on there and links on there to various companies where you can find out more information. So the second stage is around having a structured maintenance approach and developing a maintenance program. And that may be something that comes naturally out of people attending one of those courses. It may be something that is assisted by talking to the manufacturers of the equipment. So for example, here, this rock crusher maintenance manual, and if we open it up, we can see that there's a maintenance log with checklists of things to do, hydraulic circuits in there showing how the hydraulic circuits work, the list of parts, and then maybe a troubleshooting chart for how you resolve an issue if there is one. So that we would see as being the suggestion to Steve, where he's got a problem with trying to reduce downtime. Does he have that in place everywhere? And he recognizes that he's got some work to do to get that in place. Why do we say that? Well, that's perhaps the background to the next stage, which is he needs to carry out maintenance. And what are the different types of maintenance that he could carry out? And for those of you that have attended our webinars in the past, you'll perhaps be familiar with this example, but here we're just looking at a machine that all of us can relate to, I suspect. So looking at a car, and we know that there are certain things on that car that when they fail, we all just replace them reactively. So if the wiper blades start sticking or the light bulb blows, then we would carry out reactive maintenance. They're relatively simple, relatively low cost, and not particularly dangerous things if they fail. There are other things which the manufacturer will tell us it's best practice to replace the cam belt after 60,000 miles or 100,000 kilometers. You change the oil after a certain amount of time or a certain number of miles. Same with filters. And why do you do that? Because time shows that they're relatively low cost changes to make that save a much larger cost, i.e. the failure of the engine. Then there are other parts on the car which are monitored continuously. So for example, brake pad wear or tire pressure increasingly is monitored on cars, and that gives you a prediction that if you don't address it soon, it's going to be an issue. And lastly, there may be things that you carry on the car, like a run flat tire, that is in case something were to happen, and we'd call that proactive maintenance. So why is that important? Let's just summarize those four areas. So reactive, preventive, predictive, and proactive. One of the adverts for this webinar was around, are you having trouble with or finding troubleshooting difficult on hydraulic system? Well, troubleshooting would really fit under reactive. It's gone wrong, and now we've got to find out why it's gone wrong. Preventive, estimate when it will go wrong and fix it before it does. Predictive, monitor its condition and fix it when necessary. And proactive, try to stop it going wrong or minimize the consequences of failure. So today we're talking about a piece of portable test equipment, one of the tools that would typically be used by service engineers in this sort of company that Steve's working for. So we're not going to look particularly at predictive maintenance, because that tends to be condition monitoring, tends to be permanently installed sensors, but we will look examples around the other three, around reactive, around preventive, and proactive. Okay, so we've talked about the first stage, inexperienced team and getting competence-based training. We've done that magically. We've put that in place. We've now got a maintenance program, and then we come down to actually what are the tests that we could carry out in order to address the excessive downtime. So the first one, as we mentioned, we'll talk about proactive. So why are we monitoring flow? Typically, flow has been considered quite a difficult thing to measure in comparison with measuring temperature or pressure. But if we just look at this little example, I think it illustrates it very well. So we've got a pump delivering 100 litres into this cylinder. The cylinder typically takes 5 seconds to travel to full stroke, and the applied load requires a pressure of 60 bar. Now, if a fault occurs on that pump and the pump is leaking or is particularly inefficient, particularly worn, if we were then to run that pump again at only 50% efficiency and it's only delivering 50 litres, flow goes into the cylinder. We're still lifting up the same load. It is still got the same operating pressure of 60 bar, but it takes twice as long to lift it up. So if we want to fault find that particular problem, there's a few ways we can do that. We need to know what the benchmark is of what the ideal flow is. So if we're lucky enough to measure it by time, then we could tell. But in many cases, we don't know that. And so the only real way to do that is with a flow meter in place. So if we put the flow meter after the pump, we can measure what the actual flow rate is. If we look at the spec of the pump, we can see what the flow rate should be coming from it. So how does that help Steve? Steve now wants to carry out some proactive maintenance on the machines that he has within the fleet. And now he's got to make a decision about what tools does he use in order to commission the attachments before they're used. Some of you may be familiar with Webtec's range of portable hydraulic testers. So on the screen there, you've got sort of 4 different categories of product. On the far left, you've got all mechanical tester. Everything on the screen there will measure flow, pressure, and temperature. Everything's got a built-in loading valve so that you can manually load the system. All of them have Interpass safety protection. We'll talk about that a bit more in a moment. Generally, as you go from sort of left to right, the flow rates go up. So on the left, that unit, the RFIK, will go up to about 270 litres or 70 gallons. The DHT and DHM will do 400 or 800 litres, so 100, 200 gallons. And then on the far right, we've got data loggers that can work with many different sensors, but including that kit that's just that little photo down in the bottom. This one here is actually ideal for mining equipment, where it'll go up to 1,500 litres, 400 gallons. So there's a whole range of different options there. What we're launching today is this unit in the middle, this new DHM, Digital Hydraulic Multimeter, because everything essentially is digital. We compare it with the unit to the left. We've got flow and temperature that's displayed digitally, and pressure in an analog gauge. Here we've got everything digital, and that gives us extra features and extra benefits that we can then share data, and we'll show a bit more in a moment of how we can share that with a mobile phone. So how does this help Steve in his particular application? So a common use case for a portable hydraulic test would be setting up the correct flow and pressure and back pressure on a breaker attachment. So here he's got an excavator with a hammer on it. Needs to make sure before the hammer is attached that he's got the correct flow and pressure going into that attachment. Why does that matter? Improves reliability, extends the lifespan of the attachment. It reduces downtime. Overall, you get better performance and you save on costs, and also make sure it's safe. You don't want to be feeding too much flow into a small unit or too little into a big unit. So that'd be applied there to a hammer. It could equally be applied to a screening or a crushing attachment, to an auger attachment, such as that. So they're relatively straightforward. You're disconnecting hoses from the front of the boom, feeding that into the hydraulic tester, feeding the oil back to tank, and carrying out a test there, manually loading it with the loading valve as required. So there's a first use case, being proactive and commissioning attachments before they're used. So another use case for Steve, he has a fleet of mining machines fitted with variable displacement axial piston pumps. He has a few concerns. Are the pumps still set as they should be? Or are some of the failures that they're seeing in the field because operators are tampering with the settings? So in order to test that, you can install the DHM on the outlet of the pump and then carry out tests under load, under no load, and see whether it's delivering the flow that he would expect. There's also the case where when pumps get replaced, the new pumps aren't preset in the factory. They have to be set in the field. And so once they're installed, you can then use the tester to then go and set up max displacement, standby pressure, compensator pressure. And so those examples you can see there with the graphs, you could do that numerically. So you could just see, right, that Q max, what am I achieving on the screen? So you could just look at that number and go, yes, I've achieved that. But equally, if you wanted to, with this device, you could also carry out a number of tests at different flows and pressures and log those points as you're going along. And then with that data, you could pass it to a mobile phone and to the Cert Plus app to produce a little certificate or a little report to show that's what you've achieved. It depends on the user as to whether that's suitable and required or not. Okay, so we've looked at proactive testing. So the next example is around preventive testing and how you can use a tester to help with that. So just with the example with the car where we're changing the cam belt on a certain frequency, there could be examples on a pump where we want to test the pump and see its performance and check how it's performing now compared to what it was when it was first installed. So in that example, you can see there the time base could be 10 years, could be a long time. The performance level, typically you would look at volumetric efficiency and say, okay, at what point do we say that the pump is now no longer efficient enough that we need to replace it? If we do it too early, let's say after 5 years, there's a potential there that we've wasted 4 years of its life. If we do it too late, let's say after 10.5 years or 11 years, it may already have blown up. So where's the ideal point? If we're not doing real-time condition monitoring, then maybe we can do periodic monitoring. So every 6 months, for example, we might carry out a test on the pump. The advantage of having a tool like the DHM is that you could also record that data, create a little certificate for it and say, okay, that pump on that day performed like this. That gives you a reference point that you can then compare back against. So when you carry out the test 6 months later, you can look at it and say, okay, it's still roughly the same performance. I'm happy, or the performance is certainly starting to degrade. I need to change it. There's the example applied to a screening and crushing machine. You can see the DHM with the phone app on the side. So let's talk next about reactive testing, so troubleshooting, and how might that work. So here we've got an example of a fan drive. Maybe the symptom is that the hydraulic system is overheating. The suspected area is the fan. It's suspected that the fan drive is not turning at the right speed. And then the question is, well, is it getting the right flow from the hydraulic pump? So there we could install the pump into the hydraulic circuit and test what the output from the pump is. This could equally apply to other pump systems on a mobile machine. So in the simple schematic you can see there, we've got the tester installed after the relief valve. At low pressure, the pump flow may appear correct. As we turn the load valve, we are forcing the pump to do more work. The pressure goes up. As the pressure goes up, we would see the flow go down. If that flow follows something closer to the red line rather than the green line, then we know that the leakage is increasing excessively and start to question whether the pump is still suitable or not, whether it's worn out. There may be another issue for the eagle-eyed amongst you that may not be the best way to do that test, because if we're testing it at 340 bar and the relief valve is set at 300 bar, then we may be testing leakage over the relief valve and not actually testing the pump. So either we've got to adjust the relief valve, or we've got to put the flow meter in a different place. So we could put the flow meter in here, straight after the pump and before the relief valve. As we mentioned before, we do have a safety system to protect the tester called the Interpass safety system, which is unique to Webtec, where, as you'll see later on, there are little burst discs that protect the tester from overpressurization and keep the oil inside the tester. So how might that look on the new DHM? So I think this is a good moment to share some video footage with you of the tester in use. So thanks to our colleague Steve, who's filmed these. I'm just going to, some of these videos are about sort of 3 minutes long. I don't intend to play the whole video, but they will be available to you after this presentation. We'll send you links to them. But I think it's useful just to kind of pick out a few snippets from them and show you the tester in operation. So the first thing we'll look at is the fact that the tester has a facility to carry out volumetric efficiency testing. So if we just go to here, interesting. Okay, technical issue there because I can't see that the video is playing. I don't know what I do about that. Just bear with me 1 second.
It's not playing at the moment.
No, but I can't see that it's going to. I don't know why.
These things always work when they're tested.
There we go.
Never...
There we go.
There we go.
There we go. They say never do live presentations. There you go. That's the
Exactly.
You can tell this is real. This is we're not robots, and we haven't pre-recorded this. This is real. So let me flick through to 38 seconds. Let's just go through to about here.
In this training video, we will be giving us maximum flow, and this will give us system pressure. That. At that point, we press the percentage point, and this will take that as 100%.
Okay, so here what Steve's showing is you've got the flow that's actually going through the tester in litres per minute there. You've got the pressure it's operating at, and we've pressed this button here, and essentially that's set the 100% condition for volumetric efficiency. We now have the load valve in there, so we can restrict the flow through the tester, and as we restrict it, the pressure goes up, and we're then looking for how much, as we can see on this graph, how much the flow drops off. So if we were just to fast forward a bit, let's go to about here.
350 bar, we can see that the flow rate has now dropped.
So here we can see, so he's loaded the system. He's now at 353.8 bar. The flow's now dropped down to 384.8 litres. And you can see that that's automatically calculated the efficiency at 96%. So what does that mean to the user? It means that there's no complicated maths to do. It's just very instantaneous. He presses one button to set the 100% situation, the reference condition, and then as he loads it, it just calculates automatically as you're going along. So the principle there is that if you're then looking at whether the pump is still acceptable or not, whether it's on this green line or the worn line, there may be a line of, let's say, I don't know, 85%, where you say, right, I've really got to replace the pump. That number is immediately visible to you. So if we look at the next example.
In this training video,
carrying out a PQ test. So same sort of situation, the tester is installed straight after the pump and before the relief valve, but we might want to actually carry out a full PQ test. So what we mean by that, we mean carrying out a test at full flow under no load, and then progressively loading it and recording the performance of the pump over those different pressures. So similar to the volumetric efficiency test, but we're actually carrying out some recordings as we go along. Let's just see how that would work. So if we just go to, let's say, about here.
In this training video, we will be simulating the test is fully, then make sure that the loading valve is fully open, so that is fully turned anti-clockwise before we start the pump. Once we start the pump, we should then have full flow and at system pressure. And in this case, we have just shy of 400 litres and system pressure of 20 bar. At this point, we then press the record button.
Okay, so Steve's taken the first log point. He can then take up to 99 log points. If we were just to fast forward, let's say up to about here. You can see Steve's now taken, he's on his third log point, raising the pressure, and he's recording to go along, fourth log point. And so slowly he's just saving different screenshots, if you like, into the tester's memory. What does that mean for you? It means you've now got that data stored, so you can save one test up to 99 points within the tester and then share that with the free to download app called Cert Plus. So if we were just to fast forward through to about here.
Okay, and in this case, we're using an Apple phone, but it could also be Android. It's fully compatible both ways. And what we're going to do is we're going to import the test from the tester. So we go to import, and on this reference line 1, we can put the test location, we can put a control number, you can put absolutely anything you want in that. At that point, you could put if the pump had been rebuilt, you could put what you'd put into it. But in this case, we're just going to put 1, 2, 3, and in reference to, we'll put 4, 5, 6. Get it right. And then press import. So we can see that we've successfully imported it. So we then go to tests, and we go to the test that we've just done. You will also see on here that you have the true flow. So true flow is showing you the direction of flow. In this case, it's going from left to right. Equally, if we was going in reverse flow, it would have gone the other way around. So it would have gone from right to left. So we can see we have across the top, we have the device, which is the serial number. We have the time date stamp. So at
square of time. So I'm just going to flick forward. So you can see that he's brought the test in successfully. You can see the data in it. What do you do with it next? So the next thing you can do is graph it.
And we can see this is litres against bar. If we wanted to output that as a PDF, we just press the export button and it wraps it all up. At that point, you could also email it to your customer or email it back to the office just by pressing the tab at the bottom.
Okay, so I think hopefully that makes sense to everybody, that we've recorded data on the tester. We've then passed that via the Bluetooth connection to the app on the phone. We've then imported that into the app, and we can then see the results. We can graph them, and then just using the standard functionality on your phone, you can then send them on, as he said, by email, WhatsApp, whatever your preferred communication method is. So in Steve's example here, this could be the people in the field sending him data from the tests that they've carried out. Okay, so that gives you a brief overview, if you like, of the ways that the tool could be used for proactive, for preventive, and for reactive testing. From Steve's point of view, Hopefully that means he gets a better reputation for the company. It improves uptime. From the point of view of Lauren, the CEO, I'm happy because the costs are down and the service levels are up. Steve's proud that he's got a team that have grown in confidence since he's invested in their training, given them a maintenance program and kitted them out with the right tools. So if we just look a little bit more now at the technical spec of the tester. So on the screen there on the left-hand side, you'll see the older design. So some of you will be familiar with our products already. The DHM 404 came out about 10 years ago. So this new design is an improvement on that. So we're going to talk about three things. We've seen them already. We'll go in a bit more detail. So one's the quick Cert Plus app, which we've just demonstrated on the video. Second is a bit about TrueFlow, and the third is a bit about Interpass. Pricing is about the same. Is the same. So it's not about the same. It is the same as the old generation. So if you ask your local distributor, they can give you a quote. So the new app, there's a few of screenshots from it. As Steve mentioned, it is available now both for iPhone and for Android. The old tester, if you're familiar with it, didn't have the Android option, so we're pleased that we can now extend that to all Android users as well. Both of those are available in the respective stores today. Both of them free of charge. There's no monetization of them. There's nothing you have to pay for, but they are used exclusively with the DHM tester. As we mentioned, they connect via Bluetooth. How far will that go? If you've got nothing in between you, it could easily go sort of 30 meters, 100 feet. If you've got a big machine in between you, it may be less than that. But certainly if you're working sort of 5-10 meters, 15-30 feet, something like that, no problem at all. So the screens we're just going to talk about a bit more, particularly the live view. So the live view is quite an exciting addition to what we've been able to offer in the past. It is, as the name suggests, the view of the live screen. So look at this example here. We can see on the screen the flow rate, the pressure, the power, the peak pressure, temperature, how many log points have already been recorded, and as Steve mentioned before, this TrueFlow arrow here. Just look at the example. So there's the tester piped up to the machine. We've got a Bluetooth connection to the phone. Maybe that the operator, once setting it up, has unloaded the load valve and then gone and sat in the cab. They can then see exactly what's happening on the screen. It might be quite nice if it suddenly starts pouring with rain. It's a bit more comfortable to do that. From the tester's point of view, it doesn't care. We've upgraded the environmental protection on the tester even further. It's IP65. We know a lot of people use these testers in really inclement environments, so we've done all we can to try and make sure that the weather's no issue at all, and the live view just adds to that by taking you slightly further away from the machine, whether that's for safety reasons or for comfort reasons, or if you want to have two people be able to see the display at the same time. So we've got one last video here just to show the live view. I'll just go to that here.
The web booth, and we can see we have the device serial number, we have the flow rate, we have the pressure, we have temperature, we have peak pressure, which is much higher than pressure. So what we'll do is reset it.
And so that's a demonstration. You can't quite see it because Steve's hand is off camera, but he's just reset the pressure on the tester, and it's immediately reset the pressure on the screen there. So literally there's no time delay at all. What you see on one screen is what you see on the other screen.
And it's also calculating the power from the flow and the pressure. We can also see top right hand corner, it's showing true flow, so it's showing the direction of flow going from left to right. Now this is a read-only device. It will not drive the digital hydraulic multimeter. It will not allow you to record any data. But the benefits are that there could be safety implications where you want to move away from the tester and you just use the mobile phone as a readout. There could be adverse weather conditions, so it's raining hard. The digital hydraulic multimeter has a very high IP rating, so rain is not a problem, but it could be for you. So you may want to get inside the cab where you've still got full control of the circuit.
Okay,
so we jump in.
We'll stop there. Hopefully that gives you a good sense of how that live view works and enables you to see exactly what's going on the tester. Let's just talk about TrueFlow for a moment. So TrueFlow is a patent pending technology that Webtec has designed in-house. Essentially, it turns a normal turbine flow meter into both a flow meter that measures flow and can tell direction. So by a combination of using the frequency transducer and some clever digital signal processing, we can tell now whether the flow is going left to right or right to left. Particularly useful. Sometimes it's easy to look on a hydraulic circuit and see which way the flow should be going through the circuit when presented with a whole load of hoses and you pipe up a tester. It's not always entirely obvious whether you got it right or not. The testers are fully bidirectional, so they'll measure flow in both directions. This way you can see which way the flow is going. On certain hydrostatic transmissions, you may be able to have the flow going in both directions and you want to test it in both directions. And this way it will record which direction you were testing at which time. As you can see on here, we've got an arrow to the right and an arrow to the left. And as Steve demonstrated, that's available. That information transfers onto the mobile phone as well. So if we look at the inside of the tester, just a little schematic, if you like, we've got the digital flow meter, we've got a digital temperature sensor and a digital pressure gauge. We've got a little shuttle valve here, so that it's always seeing the high side of the pressure, irrespective of whether you're using it from left to right or right to left. We've got the loading valve here to restrict the flow and to raise the pressure. And then we've got a bypass system here with two burst discs, which form the Interpass system, which will rupture in the event of overpressurization. Let's just talk a bit more about the Interpass system. So this is a cut through the flow meter underneath, and there we have the two burst discs inside. We supply spares inside the tester in case they fail. The advantage of this system is that if you were to overpressurize the system above what the discs are rated to, a standard that's 420 bar, then the discs rupture and the oil just passes through the middle of the load valve. So it doesn't matter how much the load valve was turned in, it will just take the path of least resistance through the center of the load valve, through the burst discs and out the back. You can carry on measuring flow, you just can no longer load the system until you remove the tester from the circuit, put a spanner on the back here, pull this olive out and replace it with two new discs, and then you can carry on working. The advantage obviously as well is that we're at no point ever seeing oil escape from the tester, and so it's internally bypassing. Okay, we're nearly at the end of the demonstration. Perhaps just a quick walkthrough on the screen that is on the main screen on the tester. So across the top here, we've got 3 different screens that you can switch between, 1, 2, and 3. So the first screen is just the display screen. You'd also use it for doing recording. We've got the TrueFlow, we've got Bluetooth connection. We've got here how many test points we've recorded. When we record a test point, it tells us the brightness, a service indicator, when the unit should be sent back for recalibration. It will tell you that. After about a year, it will start warning you, and a battery indicator. And then the largest numbers are reserved for the actual flow and the pressure. The units of measure can be changed by the user when they switch on the device. They can switch between litres and gallons, for example, between bar, PSI, kilograms per centimetre squared, and megapascals. That's also true of the peak pressure that's held here, the temperature of the oil, and then there's a dynamic calculation there of the power in kilowatts or in horsepower, depending on the units that you select. And then you can select the second screen, gives you the opportunity to measure volumetric efficiency, and the third screen is just to look at the test results that you've recorded. And all of that's controlled using these buttons across the front here. We just look at the different models available. There are 4 different models, 2 rated up to 400 litres, roughly 100 gallons, and 2 rated up to 800 litres, roughly 200 gallons. As you can see, they're rated 420 and 480 bar. And really the difference is generally BSP or SAE, and then the larger models are both SAE, but one's calibrated in litres and one's calibrated in gallons. And you'll have evidence of that because in the box it comes with a certificate that says that it's been calibrated. And that is all we've got in terms of the overview of the tester. I hope that's been useful for people to understand a bit about the DHM and how it fits into hydraulic system fault finding. For more information, feel free to scan the QR code on the left. As Sam mentioned, there will be an email coming out after this, which will have links to various pieces of information. If you're interested in finding out more and getting a quote, then please go to our website. The picture there is a map of all of our different distributors around the world, the red dots representing the distributors. So we do have pretty good coverage. Please get in contact with our local distributor or your local distributor to get a quote. And I think that's it. And other than any other questions, Sam, have we got any questions that anybody's raised on the way? Or
yeah, there's one. Yeah, thanks for that, Martin. Steve's been answering some of the questions in the chat, and there's just one I've seen about the language of the app that was in German, and I've just had a look on the app myself of how to change the language, and can't fit. I need to ask engineering how to do that because it is in multiple languages, and I'm not sure why that's showing you in German. So I'll come back on that and maybe follow up with you with that.
But it's a good point to make there that it is a multilingual app.
Yep.
So the tester itself, the screen on the tester is basically just numbers. So no real need for language on that. When you transfer the data to the app, you can select your language. At the moment, I think it's in
French,
4 or 5
German,
languages.
Spanish, and English. Yeah. Yeah.
Okay.
English, French, German, Spanish at the moment. And so I will circle back with that, and I'll follow up afterwards with that information. We are going to start, excuse me, to video some how-tos, put some more information on the website of how to use it. So I'll do that. Just following up on what Martin said. So this afternoon, this will be sent out. You'll get a link to this recording, so you can watch it again or share it or watch it if you haven't attended live. I will send out an email either this afternoon or tomorrow with a survey. It would be really appreciative if you could fill that in. It's very quick, 6 questions, just to let us know how we can improve, how we're doing. And I will include links to videos that we've shown here, and maybe some other ones that we think are of relevance to the tester. So look out in February. We're going to have a lot more information coming out as we go through the launch process. And I think that's it. If there is any questions,
sorry, Sam, let's just add a couple of things to that. So from the point of view of timing, the product goes into production next week. Many distributors have already placed orders for the unit, so we do expect there to be good availability from February onwards if people are interested in purchasing a unit. From the point of view of feedback, we always welcome feedback, as Sam's mentioned, both to this webinar, but also within the device, within the app. There is a feedback button top right. Feel free to send us comments. Like all software, when it's first released, there's a chance we may not have got 100% right. And we have designed the software in-house, and we do have the opportunity to bring out new releases. So please, if you see something that you think could be made better, then do let us know, and we will add that to the list.
Yes. Yeah. And
is there anything else?
Oh.
You mentioned the price earlier during the presentation. Can you there's a question on the price. Is the price equal to the DHM 404?
It is, yeah. So the DHM prices hasn't changed from the old to the new generation. Clearly, there's depends what currency you're looking at as to exactly what the price is. But if you talk to your local distributor, they can give you the price.
Excellent. Okay. Well, unless there's any other questions, feel free to unmute yourself now and ask. But if not, by all means, get in contact with us after this, and we'll help. And yeah, if there's nothing else, then just thank you all for joining us. I think we've had a good attendance. It's been a good presentation, so thank you, Martin. And I'll be in touch in the next day or two with some more information. So thank you all.
Yeah.
Thank you. Thanks for having us.
Thank you to the team who helped put this together.
Yeah, absolutely. Thank you, everyone. Thanks to Steve as well for those videos.
Yeah.
I'm going to stop recording.
There's another question.